Hello friends, today's topic of discussion is elements of successful product design. Objectives of Objective of today's lecture is to study elements of successful product design. So we are going to see 5 elements of successful design. The first is cognition, ergonomics, third is utility, fourth is image and fifth is ownership. Now we can see the 5 elements of successful design viewed by user as well as the designer. 5 interdependent elements contribute to good design that we have seen: cognition, ergonomics, utility, image and ownership. These 5 elements define the human interface. Once you have established the purpose for your product and understand the user population, they ensure a useful and functional dialogue. A user's view of an interface differs from yours. Both user and designer form conceptual models of how the instrument works. Unfortunately, those conceptual models often differ vastly. Your goals as a designer is to create one conceptual model of the product, or at least to accommodate both models. So here, this diagram is basis from which users and designers view a product through the 5 elements of design. The conceptual model of a product is built on these 5 elements. If you don't make provision for all 5 categories, called product interface levels, your product is deficient. So, the first one, cognition, involves the mental tasks and computations involved in operating a device and relates to the intuition or expectations of the user. The second, that is ergonomics, as per user's view, it's fit, and from designer's view, it is form. Ergonomics deals with traditional concerns of human factors. And the third, that is utility, measures ease of use and is a differentiating factor for a product in competitive market. The next one, that is image, it represents more than the styling of a product. It includes the user's perceptions of the instrument and its operation. And the last, that is ownership. It is the level of commitment that a user exercises to use your product. So, these are the 5 elements intertwined to provide a basis for conceptual model of a product. The cognitive complexity for performing a particular task ties directly into the utility of a device. Image, it often enhance ownership, while ergonomics may place buttons where a user might expect them, thus simplifying a task. So we can see here one example that user want to understand a product and have control over events. If your instrument is difficult to use, people won't use it in spite of its capability. Have you ever tried to use a remote control for some consumer electronics or program or VCR? Most people never learn to use full range of functions because of the complexity of use. Perhaps you, like me, have a VCR that continuously blinks, for example 12, because you have not figured out how to set the clock. Now, here we can see a remote control for a stereo system. It has 32, or it has number of identical looking buttons. Who is ever going to remember all of them? So we will go through one by one the elements of successful design. The first, cognition. Obviously, it involves mental tasks and computations involved in operating a device. The cognitive aspects of instrument design have many ingredients, including learning, then memory, then organization, and the consistency and user capabilities. Most of these ingredients come to the force in graphical user interface that provides the dialogue between the user and the instrument. Cognitive aspects, the first, that is learning. Nearly every device requires learning by users before they can operate it. Some devices are more obvious or intuitive and therefore requires less time to learn. Novices usually need more time to learn than experienced people that have used similar tools. Obviously, time required will be more. Then we can find out that is GUI, graphical user interface. Then we need to again remember that which are the icons, windows, menus, buttons, knobs. For example, in the instructions. Now, rules for the complex systems. Here, provide incremental instructions for unexperienced users. Second, make experts more efficient. Give users a relevant context so that they can choose the next step also. So these are the rules whenever we are going to design a complex system by learning. Now the second aspect of cognitive, that is memory recall. It plays important role in ease of use. It has short-term memory connects events here. Memory recall and cognitive processes play an important role in ease of use. Simplifying the amount, content, structure and learning of knowledge will improve the ease of use. The user's short-term memory connects one event to the next during interface dialog. It has capacity of about 5 items. Don't require the user to remember sequences of operations, items or locations that burden short-term memory. Next, memory recall has two psychological components, recall directed searches and the second one, that is recognition based scanning, that must be considered to simplify retrieval of information. Recall directed searches use remembrance to retrieve the desired information, for example, combination of keystrokes to initiate operation. In case of recognition-based scanning, looks for familiar landmarks or to navigate decision tree or retrieve information. For example, we can find appropriate icons in completing the operation. Now, the third cognitive aspect, that is organization. Organization puts information where users expect to see it. For instance, category menus are better than alphabetical or random organization. Organization should be simple and concise with few components. Too many colors, windows, relays and character sizes will distract the user and hide the relevant information over here. Ultimately, the user should have the final say in the organization of the interface. Then the fourth one, cognitive aspect, that is consistency. Consistency is the hallmark of intuitive operation. Consistency in form, color and operation promotes understanding, training and acceptance by the user. Each user forms a mental model of the instrument. A good mental model is necessary for the user to employ the device effectively. Now the fifth one, that is user capabilities. The abilities of the user population must be considered. Users vary in experience, frequency of use and whether they are images or non-images. Since novices don't know the terminology or syntax of commands, they should be allowed to choose from menus or to work in a form filling mode. After some hours of experience, they will need the possibility to turn to command mode. If novices are not sure about semantics, well-designed icons may be helpful in this case. Then the second element of successful design, if you remember, it is ergonomics. Studies in human factors have traditionally concentrated on the physical layout of interfaces. A classic example is arrangement of top controls. How easily do they map to heating elements? Human factors focus on accessibility, arrangement and fit to make a product usable. So, human factor, it focuses on accessibility, arrangement and fit to make a product usable. Ergonomic data provide a rough baseline or a starting point for an interface design. Now, here we can see that the measurements are when some measurements are we can find out, that is how should be the chairs adjustment, how should be the screen position to avoid reflection glare, clearance under work surface, feet flat on the floor, thighs tightly, slightly, tilted slightly. So that things we need to remember. So in ergonomics, we are going to see anthropometric data, workplaces, lighting and cues. So anthropometric data, human measurements are used over here. So statistics on size, weight and reach of general populations exist in numerous sources. These statistics constrain the physical dimensions of a workplace. Here we can see some human measurements are used for anthropometric data. These are the here we can see instruments may be used in variety of situations over here. The capability of the user populations varies with age, sex, size, mobility, coordination, reaction time, training and experience, and cultural background. Don't just apply these statistics to an average user and assume that your work is done. Each task needs refinement to suit the particular group of users. Now some things are given that we can do. Design workplaces with these rules in mind. Avoid awkward positions, use normal limb movement and reach limitations, minimize fatigue, reduce hazards, reduce distracting noise, control temperature and humidity. Here we can see some examples of accessibility in maintaining the equipment. Here, the one example we are having like size of opening over here and the task. So this shows the grasping an object, grasping a box with both the hands. So these are the measurement that we need to always remember while accessibility in maintaining equipment is to be considered. Now, moving towards the next one, lightning. Illuminating the instrument and workplace requires attention to. Lighting, intensity, angle, and uniformity of coverage are important concerns. Glare can be distracting or even hazardous if it obscures important information on computer screens and panel display. You need to know the environment where your product will be used to select appropriate lighting. Now we can see some cues. Cues are basically indicators of functions. Cues may be visual, pictorial, auditory and tactile. Each type of cue has unique advantages in the operation of devices. Visual indicators provide rich cues that have special context sensitive and quickly recognized attributes. Lamps give active visual cues. They can indicate the following, that is whether a function is active, mode of operation, warnings. Many products use a small LED to signal when power is on. This cue is important when someone is trying to diagnose a malfunction. Using too many lamps can hide a particular event because human senses accommodate to multiple conditions that are similar. Then the pictorial symbols, the second one. It describes a situation quickly and efficiently. Symbols also make instruments easier to use for people who speak other languages. A stop sign, for instance, it is familiar, everyday pictorial symbol. Such symbols suit certain displays and some are illustrated over here. So here we can see some pictorial cues. We can identify the pictorial cues over here. The symbols are given. So obviously if anyone sees this symbol, we can easily identify this is for battery or charge. The next symbol here, any guesses? This is for fuel. Then the third one, oil pressure or feel. The fourth one we can find out easily. It is giving the hint, that is it is for temperature. The next one, it is for alarm or public addresses. This is as simple as these are the warnings, and the last, that is telephone. So these are the pictorial cues over here. Now moving to the next one, that is auditory cues. They are excellent for signaling unique and infrequent conditions. They have low information density and are good for warnings. But too many different sounds are confusing and eventually ignored. How many times have you been confused by an automobile with multiple alarms? Is that buzzing for keys in the ignition or the headlights left on or what? Be careful to set the volume appropriately. Too loud and you will startle and upset users. Too quiet and they will not notice. So it's depends on the application which is to be selected over here. Appropriate means fitting the level of concern. Some warnings must be insistent for hazardous operations over here. Tactile cues can use size, shape, force and texture to differentiate functions. They are good for controls that an operator manipulates without looking away from another task. Tactile cues, this last one, the tactile cues, they have size and shape limitations. They cannot be very small or subtly shaped. Cues must usually be large enough to grasp with several fingers and have significantly different shapes to allow differentiation of functions. Different shapes can provide an important safety factors by differentiating certain controls such as those found in an aircraft or a power plant. So we have seen the types of cues. Cues are basically indicators of functions. The types are visual, pictorial, auditory and tactile. In visual, we have seen so many advantages are there. Easily you can find out that is what is the meaning of that cues by seeing only. That means if any LED is used, any lamp is used for an electronic product, for example, so you can easily find out is it used for to indicate that the power is on or to indicate that whether a function is active or any mode of operation. Normally we can see to start any motor or any instrument, the LEDs or the lamps are used like so that you can find out easily that is red and green lights or lamps or LEDs are used. So you can easily find out that is if you want to start that instrument, the green light will be used or green LED will be used to show that the machine is running and all. If it is in stop mode, we can easily find out. If it is in red color, so we can easily find out that is it is in stop mode. So that is for the visual. Then for pictorial cues, you can see some standard symbols are used that already we have seen for the temperature, for to give the warnings, to tell for the indicating that for telephone is available or that facility is available, or for alarm or public addresses also. Auditory cues that are excellent for signaling unique and infrequent conditions, but the main thing that we need to consider that is volumes. Setting the volume appropriately, it is important. It should not be too loud or it should not be too quiet also. Now, considering the tactile cues, we can use the size, shape, force and texture to differentiate the functions over here. So that is about the cues. The last one, utility, it measures how well the expectations of the user are met over here. It affects primarily the feel of the user interface and includes simplicity, minimal operations and easily remembered memory processes. So for example, here we can see a software command. Now considering the image is very important to the success of a product. So we need to always consider the dimensions, perception, operation and impact of the same over here. Now coming to the last one, that is ownership. It is the commitment to a product by users, customers and designers. User invests time, effort to learn and use the device. Customers spend money and time to investigate and purchase the device. Designers invest their energy, time and emotions to develop the device. All this represent a considerable commitment to using your product. Have you made it worth their while? Image and ownership are closely linked by emotional and perceptual aspects of a design. Like image, ownership is difficult to measure. The elements of cognition, ergonomics, and utility all contribute to a user's commitment to a product. Other users can be powerful influences toward ownership. If they really like the product, they can sway other people to use and accept it. In this, we need to consider the cost. Obviously, pricing is important in ownership. The cost must be commensurate with the capability of a device and the service that it renders. Customers are happy to pay the appropriate cost if the device meets or exceeds their expectations. Then coming to the good design, careful and thorough applications of the other elements of a design will go a long way toward influencing users to commit to your product. Instructions, appropriate training and instructions will improve the user commitment. And last, that is influencing and marketing. So this is again important thing over here. This is the last case, that is finally sales and service influence ownership. Consciousness and truthful marketing with a build build a faithful following of the customers. So it is important thing, that is influencing and marketing. So whenever it is about any electronic product or any product, we need to consider all these elements and then the designing should be done accordingly. Thank you.